Hi guys, my name is Shubhang, Chemistry Master Teacher at Vedantu. Today we are going to talk about KVPY 2019 11th standard, that's essay part 2 and chemistry subject. It's the very first question and the question is PbO2 is obtained from, and we have been given 4 reactions here. Okay, so the first is PbO with HCl, that is an acid-base reaction to form a salt. The next is thermal decomposition of lead nitrate, that is the standard decomposition of metal nitrates. Reaction of Pb3O4 with HNO3, specifically dilute HNO3. And the fourth one is oxidation of lead with air at room temperature. So let's study each and every reaction one by one. Okay, the first one was reaction of PbO, which is an amphoteric oxide with HCl. So when we have an amphoteric oxide and an acid, they will react with each other to form a salt and water. Generally, these reactions are non-redox, and here we know that Pb2 plus is stable due to inert pair effect, and therefore it will specifically be non-redox. Now, the next one was lead nitrate ka heating effect. So we know that when metal nitrates are heated, they get converted into their stable oxides and NO2 and O2. These are released as gases. So in the second reaction, we get stable oxide PbO formed and not PbO2. Now, in the third case, we have Pb3O4 ka reaction with dilute HNO3, right? So Pb3O4, if you remember guys, is a mixed oxide. It's PbO and PbO2 ka mixed oxide. That means we have Pb2 plus as well as Pb4 plus. Now, when we take dilute HNO3 guys, now remember dilute HNO3 is not a strong oxidizing agent. Neither it will react so easily. So lead oxide being amphoteric dissolves in the acid, forming lead nitrate with +2 state, but PbO2 remains behind as an insoluble precipitate, brown colored. Right? Now, what happens to the hydrogen? Hydrogen is released as water. Suppose this was concentrated HNO3, then what will we get as the product? Let's discuss that. Suppose if this is concentrated HNO3, what we would like to do is CPB is in +4 oxidation state. It likes to go to +2 due to inert pair effect. That means it would want electron. Nitrogen is in +5, cannot get oxidized further. Hydrogen is in +1, cannot get oxidized further. So the only option is oxygen gets oxidized here. So if we take concentrated HNO3, we get lead nitrite, Pb +2 nitrate and O2 as well as water formed. Oxygen is then released. Okay, so C is definitely our answer. Let's talk about option D. Option D was oxidation of lead in air at room temperature. So at room temperature, it will get converted into stable oxide, that is PbO itself. Hence answer is C. Okay, thank you so much for joining us guys, and stay tuned for our next question.